Well, let's continue chapter 14, 14.8. We're going to talk about the objective method of Lagrange multipliers. We use this method for constraint optimization. Constraint optimization. What do I mean by that? For example, suppose your job is to construct an open box, and you have some financial constraint. You want to maximize the volume of the box. And you can only pay, for example, $3 per square foot for the base, and you can only pay $2 per square foot for the sides. Question is, what is X, what is Y, what is Z that actually gives me the maximum volume? What are the measurements? So here's another type of question that we saw before, but I want you to see this question and try to connect it with the concept that we learned in this class, gradient. So suppose we want to find the maximum area. Find the maximum area of a rectangle that is inscribed in the following ellipse. Inscribed in the ellipse, x squared over 9 plus y squared over 16 equals to 1. Well, let's take a look at the graph. Let's graph these. Here we have x-axis, here we have our y-axis. For our ellipse, 3, -3, 4, and -4. So let's connect these. And actually we have our ellipse here. And the rectangular shape, suppose that shape is just here. What is our goal? Our goal is to maximize the area of this rectangle. Let me just use a better line here for you. Suppose the sides are parallel to each other. Okay. Not that bad. So, suppose you have x, you have y. Very well. Let us write down function f of x and y, which is the area 2x, 2y, or f of x and y is equal to 4xy. What is our goal? Our goal is to maximize this function. Okay, before going any further, think about this. What are the little curves of this function? To find the little curves of this function, we set the function equals to a constant like k. So y is equal to k over 4x. For different values of k, you actually get just some hyperbolas. So let us just graph them, some of them, hyperbolas. Little curves of function f and little curves for your ellipse. So what is our goal? Our goal is to actually find the point that level curve of your function f is tangent to the level curve of your ellipse. Okay, remember that when we talked about gradient function, we said that the gradient at the point is actually orthogonal or perpendicular to the level curve of the function at that point. So, level curve of these two functions. And we're looking at the gradient vectors. They are parallel to each other. It means that they are scalar multiplication of each other. So you can write gradient of f equals to a constant like lambda gradient of g. Okay, guys, take your time. If you have any questions. Okay, for Lagrange multiplier itself, Lagrange multiplier method. So this method says to find the maximum or minimum. So find the maximum or minimum value of function f of x, y, z subject to. So we have a constraint subject to the constraint x, y, z equals to k with the conditions. Remember that these extreme values exist and the gradient of function g is not zero on the surface of g of x, y, z equals to k. If you have these conditions to find the maximum or minimum value of function f, find all x, y, z, and lambda values by solving gradient f, x, y, z equals to lambda, the gradient of g, and using your constraint x, y, z equals to k. After finding all of these values, we plug those into the function. We calculate the function f of x, y, z at these values. The largest value is actually the maximum of your function. The largest number is the maximum value of the function, and the smallest value is the minimum value for the function. And the smallest value is the minimum value for the function. For the function f. Please take your time, write these down. This is lambda. This is just a constant. If you have any question, please unmute yourself or use chat to ask the question. So let us go over one example. We're still on page 1. Example. This example says, find the extreme values of function f of x, y, z equals to x squared plus 2y squared on the circle x squared plus y squared equals to, we have a unit circle, 1. Very well. How do we find the extreme values or the maximum, minimum of the function constrained to the circle? Very well. So let us start by writing. Let us set up the equation. We need to find the gradient of f, x, y, z. And set it equals to lambda, the gradient of function g, x, y, z. So the gradient of f, 2x, 4y, must be equals to lambda, the gradient of g, 2x and 2y. 2x and 2y. Note that you have your constraint here. X squared plus y squared equals to 1. So we're using these two. So 2x is equal to 2 lambda x. And 4y, the second components, we have two vectors, the second components must be equal to each other. And we have 4y, which is equal to lambda 2y. There we go. Let's take a look at first equation. From first equation, you have the following. Your lambda is equal to 1 or x is equal to 0. If your x is equal to 0, it means that your y squared is equal to 1. So y is plus minus 1. Now, if I just plug in lambda into the second equation, what do I get? I get 4y equals to 2y, so it means that my y is equal to 0. If y is equal to 0, then using your constraint, which is x squared plus y squared equals to 1, gives you x squared equals to 1, or x equals to plus minus 1. So when x is equal to 0, your y is 1 or negative 1. When your y is equal to 0, your x is 1, negative 1. So 1, 0, negative 1, and 0. Here you have 4 points. Now we're looking at our function. So if I plug in 0 here into the function, I get 0 squared plus 2, which is 2. If I plug in 0 negative 1, I get 0 plus 2, which is 2. And if I plug in 1 and 0, I get 1 plus 0, which is 1. And if I plug in negative 1 and 0, I get 1 plus 0, which is 1. There you go. The maximum value of the function is equal to 2, and the minimum value of the function is equal to 1. Let's take a look at the graph. Very well. As you can see, you have your function f, and you have your circle. As you can see, the gradient vectors needs to be parallel to each other at 4 points, 0, 1, 0, negative 1, 1, 0, and negative 1, 0. We see they are actually parallel to each other. Okay, very well. So just take a look at the movement of the yellow point on both of these two. And finally, a checkpoint for you. On page 2, we have the question asking, Find the points on the sphere x squared plus y squared plus z squared equals to 4 that are closest to and farthest from and farthest from the point 31 negative 1. Point 31 and negative 1. Take your time. Very well. So first of all, we have the distance function. The distance function, d squared. Now we define it for simplicity. D squared is equal to x minus 3 squared plus y minus 1 squared plus z plus 1 squared. Very well. In Lagrange multiplier method, we need to set the gradient of our function equals to lambda, the gradient of our constraint. So the gradient of our function is 2 times x minus 3, comma 2 times y minus 1, comma 2 times z plus 1. And lambda, the gradient of g, is 2x, 2y, and 2z. Very well. So what do we have here? We have 2 times x minus 3 equals to 2 lambda x, and then you have 2 times y minus 1 equals to 2 lambda y, and here you have 2 times z plus 1 equals to 2 lambda z. Very well. So first of all, we can cancel out all of these 2, they are common elements. So by solving the first equation, we're trying to write down x in terms of lambda, y in terms of lambda, z in terms of lambda, and then use our constraint. Remember that the last equation that you can use is your constraint equation. Okay, so here, if you write x in terms of lambda, you get x minus lambda x equals to 3. So x is equal to, let's write it down, 3 over 1 minus lambda. So that lambda cannot be equal to 1. From the second equation, you get y minus lambda y equals to 1. So in this case, your y is equal to 1 over 1 minus lambda. And from the third equation, you get z minus lambda z equals to negative 1. And here your z is equal to negative 1 over 1 minus lambda. Okay, now we're taking all of these and we substitute them in the last equation. So x squared, we get 9 over 1 minus lambda squared plus 1 over 1 minus lambda squared plus 1 over 1 minus lambda squared equals to 4. Very well. So you get 11 divided by 1 minus lambda squared equals to 4. What's the meaning of that? It means that 1 minus lambda is equal to plus minus square root of 11 over 4, or your lambda is equal to, so we have two values for lambda. Lambda is equal to 1 plus minus square root of 11 divided by 2. We found two values for our lambda. Now we have to calculate x, y, and z. What is your x? What is your y? And what is your z? So if you plug in the lambda into x, your x is equal to 3 divided by, if you use a positive value of 1 minus 1, it's going to be square root of 11 over 2. So you get 6 over square root of 11, and x is equal to negative 6 over square root of 11. Okay. Then what else do we have here? for y, we get 1 divided by 1 minus 1. So you get 2 over, let me see, 2 over square root of 11. And your y is negative 2 over square root of 11. And then for z, if you plug in, you have a negative sign on top of it. So you get negative 2 divided by square root of 11. And your second z is 2 over square root of 11. Now we have to plug these into the distance function, find the maximum and minimum values. So let us calculate these. This is your first point, and this is your second point, the distance function. So let's see here. Okay, so just let us take a look at this. X minus, so you have 6 minus, and then here you have 2, then you have negative 2. Okay, if you plug these values in, by plugging these values, you get smaller numbers, and by plugging these values, you actually get larger numbers because you have 2 negative signs, so, and then you square it. So it seems like at this point, you get the farthest distance. Distance, at this point, you actually get the closest distance. But do the calculation and make sure you have the correct value.